Using trigonometric functions, we're modelling with trigonometric functions, which means we've got some real life applications of advanced trigonometry. So the question here is an entomologist studying a variety of mosquitoes. So an entomologist is someone who studies insects. This one's looking at mosquitoes. Observes and estimates the population of the colony for 16 weeks. So that means we're interested in time being up between 0 and up to 16 weeks. Whenever we're talking about time when we're modelling, we're generally always talking about positive values of time. So if we're thinking of this, look, on the y-axis we're going to have the population, and on the x-axis we're going to have time. So our domain is between 0 and 16, because we're told we're modelling for 16 weeks. How about on our y-axis? All right, on our y-axis, we're going to have, let's think about what's going on with this trig function. What's the translations involved in this trig function? What's the value of A, B, C, and D? Let's identify that in order to help us figure out our V window. What's the amplitude? 2,000, isn't it? It's always the number in front of the sign, so that's 2,000. How about our vertical translation, D? What's the value of D? D is positive 7,000. All right, so we could have written it over this side. We could have written plus 7,000 at the end. Sometimes it will be at the start. So that means, right, if we're thinking about the function, the highest that it's going to go, like if you think about the graph of it, its principal axis is at 7,000, and then it's going up 2,000 higher than that. Okay, so what's the highest it's going to go to? If the principal axis is 7,000 and the amplitude is 2,000, then the highest point is going to be 9,000. So that means for our V window for y, we should set it between 0 is less than y, which is less than, we'll go just a little bit higher than 9,000. Let's go for 10,000. And so let's sketch that function in our calculator. So we're going to go into graph. The function is 7,000 plus 2,000 sine, make sure you put brackets here as well. We've got pi x on 8. Now I understand up here in the question it's got it in terms of t. Whenever we put it in our calculator, we're always going to use x as our variable. Okay, put that in, and then we press Shift V window. I'll pause for a moment. Alright, so for x, we're going to go from 0 to 16. And for y, we're going to go from 0 to 10,000. Beautiful. So it looks like it's got a period of 16 weeks, doesn't it? Time is on the x-axis, time is in weeks. So we're going to use this graph to answer all of the questions. All right, so has everyone got the sort of the graph there? Mary, you good? Yep, Megan? Excellent. So, part A says, find the initial population. So that means when the time is 0, what is the population? We're finding P of 0. Now we could put 0 into this equation and solve it. We could put 0 in there and solve this equation, or we can G-solve it on our calculator. Let's get familiar with using our calculator. So we'll go G-solve. We want to do a y-calc. We want to know the population when time is 0. Time is on the x-axis. When time is 0, the population is 7,000 mosquitoes. Okay, part B, determine the estimated population after 6 weeks. So this means when time is 6, what is the population? I'm going to show you guys a little bit of a life hack here on the calculator. Press F1 for trace. Okay, so that means you can trace along your calculator. But now, whenever you press any number, like we want to know 6, it's going to take us straight to that x value for 6. Okay, you can press 7, you can press 8, and it takes you straight to those values. So rather than having to go through that process of G-solve, pressing the cross arrow, we can just press trace and then press the number that we receive. So the population after 6 weeks, that means when time is 6, what is our y value? We've got 8,414, and so to three significant figures, that's going to be 8,410. And don't forget a unit, we're talking about mosquitoes. All right, C. What is the greatest population and when does it occur? So the greatest population is going to be when we have a max. So we're just going to go G-solve, max. We have a pop on the y-axis. We've got 9,000 mosquitoes. When does it occur? It occurs when time is equal to 4, so at 4 weeks. So notice how I've answered everything here in the context of the problem. On the x-axis we've got time, and on the y-axis we've got number of mosquitoes. So we have maximum population and when it occurs. When is the population 8,600? So what this is saying is P of t equals 8,600. What is this value of t? What is the value of time? And so now we need to do a x-calc. So we've g-solve across, we want to know the time when the population is 8,600. Okay, and we've got 2.361, which is 2.36, those are three significant figures. Do we need to consider anything else? So, like if here's a rough sketch of the graph, right? Here the population is 8,600. It says, when is the population 8,600? Here it is. Are there any other instances? Yeah, right there. So we just press the cross arrow. That's going to bring up the other circumstance. We'll have 5.638. And we're going to round that one to 5.64 weeks. ABCD. E. When, during which interval does the population exceed 8,000 mosquitoes? So, again, we're doing an x-calc. We're interested in the time when the population, I've done that round the wrong way. Graph, G-solve, x-calc when the population is 8,000. So the population is 8,000 when t is 1.33. 1.33 recurring to 6.6 recurring. All right, let's state that using mathematical notation. So between 1.3 is less than or equal to t is less than 1.6 recurring, we have more than 8,000 mosquitoes. Maybe the entomologist is going to say between 1.3 and 6.6 weeks, you need to take some insect repellent outside to save yourself from the mosquitoes. And then we have draw a graph of the function. So to get full marks for the graph, right, what you're going to need to do, you're going to need to label your axes, T and P of T. You need to sketch all the appropriate information. So we're going to have the principal axis here, which is 7,000. As long as you're illustrating the amplitude, it goes up to 9,000. Amplitude is 2,000, it's going down to 5,000. We can put a little squiggle here to show that it's not, that part's not to scale. And then we need to label the function as well. So we need to write this on the graph to show that this is the function of, this is the graph of this function. Now, this is the part that stumps people, is the V window. Okay, so let me really emphasize that point. The V window, all right, so your Y value is always going to be between 0 and the amplitude plus the vertical displacement. Okay, amplitude plus the vertical displacement. That's all, and maybe a little bit more. I did a little bit more, but that's always going to be your Y. And then for X, you should always be given the domain. Okay. Otherwise, the domain is just a period. All right. Period is 2 pi divided by b. So so you can figure out what the period is. Okay, that's all. Let's have a go at it.